Hi, I'm Syed on Maths Online. Welcome back to my channel. Today's topic is Inverse Laplace Transform. We already seen in Laplace transform some basic Laplace transform formulas. Using those Laplace transform formulas, I'll try to write down the inverse Laplace transform formulas. So let me write down some of the formulas that we have studied. So Laplace transform of A. Its formula is A by S. And Laplace transform of e power of at. Its formula is 1 by s minus of a. Then you have Laplace transform of cos hat. Its formula is s by s square minus of a square. Then Laplace transform of sin hat is a by s square minus of a square. Then Laplace transform of cos at. Its formula is s by s square plus a square. Next you have Laplace transform of sin at. Its formula is a by s square plus a square. Then Laplace transform of t power of n. Its formula is gamma of n plus 1 divided by s power of n plus 1. In this case, n is any constant. Similarly, we have Laplace transform of t power of n. Once again, this formula will be n factorial divided by s power of n plus 1, where n is an integer. So it is a positive integer. If n is a positive integer, then we use this formula. All this set of formulas we have already studied earlier in the Laplace transform videos. You can watch my earlier videos for all this set of formulas. Now, I'll try to write down these formulas in terms of the inverse Laplace transform. So if I write down the inverse Laplace transform, if I take this L on the other side, we'll be getting L inverse. So L inverse of A by S. So its formula will be A. Becomes L inverse of A by S, and here we will be left out with A. So therefore we have L inverse of A by S to be A. Similarly, the second one, if I take L on the other side, becomes L inverse of 1 by S minus of A, and its formula will be e power of at. Then we have, if I take L on the other side, is L inverse of s by s square minus of a square. Its formula will be cos hat. The next formula will be L inverse of a by s square minus of a square. Its value will be sin hat. Next you have inverse transform of s by s square plus a square. What will be its value? Cos at. Cos of at. Then we have inverse transform of a by s square plus a square. Its formula will be sin at. Similarly, the next one, suppose if I take the inverse transform, the other side becomes L inverse of So this gamma of n plus 1 can be rewritten. I will just take in terms of s. So 1 by, if I am taking s power of n plus 1, then its value will be how much? D power of n. What about this gamma of n plus 1? Suppose if I just cross multiply this gamma of n plus 1, it comes in the denominator. So this gamma of n plus 1 value which is there, I am just trying to cross multiply its value. This value comes in the denominator, so I can cross multiply and write down that as gamma of n plus 1. In the same way, if I write inverse transform of, so this is 1 by s power of n plus 1 if I write, which will be equals to, this is t power of n. And this n factorial, I'll just take it over here, just cross multiply, will be getting divided by n factorial. So this formula can be used whenever the value of n is a constant. This formula can be used whenever the value of n is a positive integer. Right? So these are the basic inverse Laplace transform that you have to know. So now let us take few examples based on this inverse Laplace transform. Some basic examples. So let me take inverse transform of, say, 1 by s. So if I write inverse transform of 1 by s, according to the formula what you have, it is inverse transform of a by s will be a. That means whatever numerator value is there, the numerator value you have to write. Now in the same way, if I want to write down inverse transform of 1 by s, what will be its value? The numerator value will be 1. Right? So that will be the required solution. Similarly, if you find out, say, inverse transform of, say, 3 by s. So according to the formula, inverse transform of a by s will be a. So what is the value of a in this case? The value of a is 3. So we'll be getting inverse transform of 3 by s will be 3. Similarly, if I write inverse transform of 1 by s minus of 2. So according to this, we know the formula inverse transform of 1 by s minus of a, the formula will be e power of at. So therefore, if I want to write down this solution here, it is e power of at. So what is the value of a in this case? The value of a is 2. So we'll be getting e power of 2t. Alright. Let us take another example. Say inverse transform of 1 by s plus 3. What I have taken? Inverse transform of 1 by s plus 3. So if I want to rewrite this one, so I can rewrite this as inverse transform also. The formula should be 1 by s minus a. So I can write this plus 3 as minus of minus 3. This plus is written in the form of minus of minus 3. So this has to be written in the form of e power of at. So e power of a value is how much? S minus a. So a value is minus 3. So minus 3 times of t you get. That will be the required solution. Suppose if I take, let us take another example. Inverse transform of s by s square minus of 2 square. So that is similar to this formula you have. Inverse transform of s by s minus a square will be how much? Cos h at. So a value is at. So in this case, in place of a, what do you have? In place of a you have 2. So therefore you will be writing cos h at. So cos h 2t. Next is inverse transform of, say, 3 by s square minus of 9. I can rewrite this as inverse transform of 3 by s square minus 9 can be written as 3 square. 9 can be written as 3 square. So which is similar to this formula that you have, L inverse of a by s square minus of a square, which is sin h at. So I can write this as sin h a. A value is how much here? A value is 3. So 3 times of t. Let's take another example. Inverse transform of s by s square plus 25, right? So if I try to rewrite this one, this can be written as L inverse of S by S square plus 25 can be written as 5 square, which is similar to this formula that you have. It is S by S square plus A square. L inverse of S by S square plus A square is what? Cos 80. So therefore, if you want to write down this value, it is cos of A value is how much? A value is 5. So 5 times of T you get. Let us take few more examples. So next example, L inverse of 7 by S square plus 49. So you can write this value as L inverse of 7 by S square plus 49 can be written as 7 square. So it will be equals to. So this is similar to this formula that I have given you here. L inverse of A by A square plus A square. The formula is what? This formula is sin 80. So this formula number 6. L inverse of A by A square plus A square is sin 80. So I can write it here as sin 80. So sin of A value is how much? A value is 7. So we'll be getting 7t. Let's take another example. L inverse of 1 by S power of 5. So I have to write in the standard form because the formula that I have is L inverse of 1 by S power of n plus 1. L inverse of 1 by S power of n plus 1. So which is t power of n by n plus 1. Or if you want to rewrite this formula, this formula can be rewritten in the form of L inverse of, if you want to just write 1 by S power of n form. In this case, let me take this t power of n minus of 1 divided by, you are having gamma of n plus 1. So whatever this power is there, that value you are getting. So here what will be getting? Whatever power is there, the same value will be getting, gamma of n. Alright. So this is similarly for this also you can write L inverse of 1 by S power of n. Its value will be equals to. So if n is there, it has to be reduced by n minus of 1 divided by, you are having n plus 1 here, the value is n factor. So whatever the power value is there, the same value you are getting over here. So if n minus 1 is there, in the denominator also you will be getting n minus 1 factorial. So now if you use that formula here, you have S power of 5, so it is 5 minus of 1 divided by, so now the question is, this is the two formulas that you have. So which formula has to be used? This formula has to be used, the second formula I have over here, this formula has to be used when the value of n is a positive integer. If it is a positive integer, then you are going to use this formula. So here you can see that this power is a positive integer, therefore I have to use the formula t power of n minus of 1 divided by n minus 1 factorial. So I have t power of n value is 5, so 5 minus of 1 divided by 5 minus of 1 factorial. So there will be t power of 4 divided by 5 minus 1 will be 4 factorial. Or t power of 4 by 4 factorial can be written as 24. So the same way, let me write down L inverse of 1 by S power of 3 by 2. L inverse of 1 by S power of 3 by 2. So if you try to see, this 3 by 2 is not an integer. So whenever you have a constant term, you can use this formula. 1 by S power of n value will be t power of n minus of 1 divided by n factorial. So if you use over here the formula, t power of n minus 1 will be 3 by 2 minus of 1 divided by gamma of n. So gamma of, so n value over here is 3 by 2. So this can be written as t power of 3 by 2 minus of 1. If you just take the LCM and simplify, 3 by 2 minus 1 will be 1 by 2. Whole divided by, you have gamma of 3 by 2. So you need to find out this value of gamma of 3 by 2. We know the simple formula of gamma of n. So gamma of n will be equals to n minus of 1 into gamma of n minus of 1. In gamma function, this is a formula you have to remember. Gamma of n will be n minus 1 into gamma of n minus of 1. There is another formula, gamma of half will always be square root of pi. These are the basic formulas you need to remember. Now let us try to first calculate this gamma of 3 by 2. So if I take n value to be equals to 3 by 2, I will be getting gamma of 3 by 2 will be equals to, here you have 3 by 2 minus of 1, gamma of 3 by 2 minus of 1, which will be equals to 3 by 2 minus 1 will be 1 by 2, gamma of 3 by 2 minus 1 will be 1 by 2, so which is 1 by 2 into gamma of 1 by 2. What is gamma of 1 by 2 value? You need to remember this value. It is square root of pi. So you got gamma of 3 by 2 value to be equals to 1 by 2 into square root of pi. So you can just plug in over here. So if you want, you can take this as equation number 1. So let us substitute the value in equation number 1. So substitute in equation number 1. So you will be getting inverse transform of 1 by s power of 3 by 2 will be equals to t power of half divided by gamma of 3 by 2. So what is the value of gamma of 3 by 2? You have got 1 by 2 square root of pi. Or 1 by 2, if you take in the numerator, becomes reciprocal. It will be 2 t power of half divided by square root of pi. Right? These are some of the examples based on all the basic formulas. I have discussed over here 8 basic formulas and I have solved all the problems based on these basic formulas.